On Christmas Eve 2024, while most of humanity was celebrating, a spacecraft the size of a small car did something that should be physically impossible. It flew into the atmosphere of a nuclear furnace burning at millions of degrees. And what it found there is about to change everything we thought we knew about our sun. I'm talking about NASA's Parker Solar Probe, which just came within 3.8 million miles of the sun's surface, closer than any human-made object in history. And before you say 3.8 million miles doesn't sound that close, let me put this in perspective. If the sun were your front door and Earth was a coffee shop 93 million miles away, Parker just walked up and knocked. It got so close, it was actually flying through the sun's outer atmosphere, a place so extreme that the temperature exceeds 2 million degrees. But here's where it gets weird. And I mean physics-breaking weird. The spacecraft survived. Not just survived, it took measurements, collected data, and radioed back discoveries that made astrophysicists around the world lose their minds. And the biggest discovery? We finally know where the solar wind is born. Now, you might be thinking, solar wind? Who cares about some space weather? But here's the thing. Solar wind isn't just some abstract cosmic phenomenon. It's the invisible force that can knock out your GPS, disable satellites worth hundreds of millions of dollars, and this actually happened. Leave 6 million people sitting in the dark. In 1989, a solar storm caused a 9-hour blackout across Quebec, Canada. Traffic lights went dead. Hospitals scrambled for backup power. And that was from a storm we barely saw coming. The solar wind is essentially the sun throwing a constant tantrum, hurling charged particles across the solar system at speeds up to 1.8 million miles per hour. Earth sits directly in the firing line. And until now, we didn't fully understand where this cosmic assault actually begins. That's what Parker just figured out. But let's back up for a second. Because to appreciate what Parker found, you need to understand why this mission was considered borderline insane when it was first proposed. Picture this. You want to send a spacecraft to touch the sun. Not near the sun. Not kind of close to the sun. You want to fly through its atmosphere. The previous record holder was Helios 2, which got within 27 million miles of the sun back in 1976. That was already considered extremely close. Parker said, "Hold my solar panels," and dove 7 times closer. During its closest approach, Parker was traveling at 430,000 miles per hour. Let me help you visualize that. At that speed, you could fly from New York to Tokyo in under a minute. You could circle the entire Earth in about 3.5 minutes. Parker is officially the fastest object humanity has ever built. And it needed every bit of that speed. Because at these distances, the sun's gravity is trying very hard to turn your spacecraft into a very expensive piece of toast. So how does Parker survive? This is where engineering becomes almost indistinguishable from magic. Parker's thermal protection system, its heat shield, is just 4.5 inches thick. That's it. Between a nuclear inferno and some of the most sophisticated scientific instruments ever built, there's a barrier thinner than a cinder block. But this isn't ordinary material. It's a carbon composite foam, lighter than it looks, and capable of withstanding temperatures up to 2,500 degrees Fahrenheit on its sun-facing side, while keeping the instruments behind it at room temperature, around 85 degrees. Imagine holding an oven mitt that's 2,500 degrees on one side and comfortably cool on the other. That's essentially what's happening. But here's the mind-bending part, and this is where space gets really weird. The sun's corona, the atmosphere Parker is flying through, is technically millions of degrees. So why doesn't Parker melt instantly? Because temperature and heat are not the same thing. Think of it like this. If you stick your hand in a 400-degree oven for a split second, you might get a slight burn. But if you touch a 400-degree pan, instant damage. Why? Because the pan has more particles, more stuff, packed together to transfer energy into your hand. The corona is incredibly hot, but it's also almost a perfect vacuum. The particles are moving at insane speeds. That's the temperature. But there are so few of them that they can't transfer much heat to the spacecraft. Parker is essentially flying through an extremely hot ghost. Lots of energy, not much substance. Still, this is not a leisurely cruise. Every close approach pushes engineering limits we've never tested before. So what do we learn from this cosmic kamikaze mission? Let's start with the big one, the birthplace of the solar wind. For decades, scientists theorized that solar wind just sort of emanates from the sun, like steam rising from a pot of boiling water, evenly distributed across the surface. Wrong. Parker discovered that solar wind is born from very specific locations, bright spots at the base of structures called coronal holes. Coronal holes are regions where the sun's magnetic field opens up to space, like escape hatches in a magnetic prison. And within these holes, the solar wind doesn't just drift out, it jets out from concentrated bright spots, funneled upward along magnetic highways. Imagine if we thought volcanoes erupted uniformly across the Earth's entire surface and then discovered they actually come from specific points where magma finds a path upward. That's roughly analogous to what Parker found. This matters enormously for prediction. If we know exactly where solar wind originates, we can better predict when dangerous streams will hit Earth. Solar wind particles take about 2 to 4 days to travel the 93 million miles to us. That's our warning window. But there's more. Parker detected something strange in the magnetic field data. Scientists are calling them switchbacks. Imagine you're driving down a highway and the road signs keep flipping to point backwards, then forwards again, over and over. That's essentially what's happening with the sun's magnetic field lines near the solar surface. These switchbacks are sudden, violent reversals in the magnetic field direction, and they appear to be caused by something called magnetic reconnection. Magnetic reconnection is what happens when magnetic field lines break and reconnect in a different configuration, releasing enormous amounts of energy. It's like the universe's rubber band snapping. These reconnection events near the solar surface seem to be pumping energy into the solar wind, accelerating particles and creating the switchback signatures Parker detected. This feeds into another mystery Parker is helping solve, one that's been bugging physicists for over 80 years. Here's something that shouldn't make sense. The sun's surface is about 10,000 degrees Fahrenheit. Hot, right? But as you move away from the surface into the corona, the temperature increases to over 2 million degrees. That's like walking away from a campfire and getting hotter. This is called the coronal heating problem, and it violated our intuition so badly that scientists have been arguing about it since the 1940s. Parker's data is finally providing answers. The spacecraft confirmed that magnetic waves, called Alfvén waves, carry energy from the solar surface outward and then dissipate that energy into heat in the corona. Think of it like cracking a whip. You put energy in at the handle, but the tip of the whip is where the energy concentrates and releases. The corona is the tip of the sun's magnetic whip. Parker also discovered something unexpected about a boundary called the Alfvén critical surface. This is the invisible line where solar wind finally breaks free from the sun's magnetic grip. Below this boundary, material is still connected to the sun. Above it, material has escaped into space, becoming the solar wind that buffets planets. Scientists assumed this boundary would be smooth, like the surface of a lake. It's not. It's wrinkled, folded, complex. Parker crossed in and out of this boundary multiple times during close approaches, proving that the sun's sphere of magnetic influence isn't a neat shell. It's a churning, dynamic, constantly shifting frontier. This wrinkled surface explains why solar wind can be so unpredictable. Depending on where and when particles escape, they carry different properties, different speeds, different impacts. So let's bring this home, literally, to your home. Why should you care about where solar wind is born? Because solar wind is actively trying to mess with your life. Right now, today, every GPS satellite orbiting Earth is vulnerable to solar wind. During severe solar storms, GPS accuracy can degrade by several meters. That might not sound like much, but tell that to an airplane trying to land in fog or an autonomous vehicle navigating a crowded street. Your cell phone signal bounces off satellites affected by solar wind. Financial transactions worth billions of dollars per second rely on precise satellite timing that solar storms can disrupt. And then there are the power grids. Solar wind carries magnetic fields that can induce electrical currents in long conductors, like power lines. During the 1989 Quebec blackout, solar-induced currents overwhelmed transformers, cascading into a grid failure that affected 6 million people. In 1859, an event called the Carrington event produced a solar storm so powerful that telegraph systems caught fire. If it happened today, estimates suggest it could cause trillions of dollars in damage. Power outages lasting weeks or months. Satellites dropping offline like dominoes. We're not being paranoid. We're being realistic. And Parker Solar Probe is giving us the tools to get ready. Here's the wild part. Parker isn't done. The mission uses Venus gravity assist to gradually shrink its orbit around the sun, 7 Venus flybys in total, each one slingshotting Parker onto a closer trajectory. The December 2024 approach? That was just one of many. And each subsequent pass brings more data from regions no spacecraft has ever explored. The mission is named after Eugene Parker, an astrophysicist who predicted the existence of solar wind back in 1958, when many scientists thought his ideas were ridiculous. He lived to see the spacecraft bearing his name launch in 2018. And there's something beautiful aboard that spacecraft. Parker carries a memory card with over 1.1 million names submitted by the public. people who wanted a tiny piece of themselves to touch the sun. It also carries photos of Eugene Parker himself and a copy of his original 1958 paper. Science, meet poetry. So, what does this leave us? We now know the solar wind is born from specific bright spots at the base of coronal holes. We know magnetic switchbacks are pumping energy into the outflow. We know the Alphane critical surface is wrinkled and complex. We're solving the coronal heating problem that puzzled scientists for generations. And most importantly, we're building the knowledge base to protect our increasingly space-dependent civilization from the sun's inevitable outbursts. Because here's the thing about our sun, it doesn't care about us. It's a 4.5 billion-year-old nuclear furnace doing what nuclear furnaces do. It will keep erupting, keep throwing tantrums, keep hurling charged particles across the solar system. Our job is to understand it, predict it, prepare for it. And a small spacecraft flying through hell itself is showing us how. The Parker Solar Probe has touched the sun, actually flown through its atmosphere, and survived to tell us secrets our star has been keeping for billions of years. The birth of the solar wind isn't a mystery anymore. It's data, it's knowledge, it's power, and every new orbit brings us closer to answers we didn't even know we needed. If this video made you see the sun a little differently, made you realize that giant ball of fire is actively shaping life on Earth in ways you never considered, hit subscribe. I dive deep into space science stories like this every week, turning cosmic discoveries into something that actually makes sense. And if you want to know what happens when the sun really loses its temper, check out this video on the most dangerous solar storms in recorded history and what a modern repeat could mean for civilization. The sun isn't done surprising us. Neither am I. End.